Assalamualaikum and good day everyone. We are from Group 3 and today we are going to present our project titled Developing an IoT Solution for Real-Time Air Quality Monitoring and Public Awareness. Before I begin, let me introduce myself. My name is Aliya binti KHAIROL ANUAR and I will be covering the introduction, problem statement and objectives for this project. Now I will pass it to my group members to introduce themselves.
Hello everyone, my name is RIDWANA HILMI and today I will be covering for the Python coding and also the dashboard on our Teams board.
Hello everyone, my name is Khalissa AZIZ and I will cover conclusion part.
Let's start with why this project is important. Air quality is something we often take for granted, but it has a huge impact on our health and the environment. Poor air quality can lead to serious health problems like respiratory and cardiovascular diseases. It can even lower agricultural productivity and harm ecosystems. The problem is, air quality isn't the same everywhere. It can change depending on the location. That's why having a reliable system to monitor air quality on both regional and local levels is so important. But here's the challenge. Not every community has access to real-time air quality monitoring systems. Why? Well, the reasons include high cost, lack of infrastructure, and sometimes even a lack of awareness. This leaves people vulnerable to pollutants like PM2.5, which is one of the most harmful because it can penetrate deep into our lungs and bloodstream. Without proper data, it's hard to take action or plan interventions. That's the gap we aim to fill with our project, creating an affordable, reliable, and accessible solution. So, what exactly are we trying to achieve? Here are our main objectives. First, we want to measure and collect real-time data for PM2.5 temperature, pressure, and wind speed. Second, we will display this data using an interactive ThinkSpot dashboard, making it easy to monitor and analyze. Third, we will include alerts and notifications for unsafe conditions so users can take action immediately. And finally, we hope this project will raise awareness and help communities make better decisions about air quality. Thank you. I will now hand over to Hanania to continue.
Hello and back again with me. So let's start with, I will walk you through um, the coding process for our smart air quality monitoring system. So which is actually real-time telemetry data to ThinkSpot. So our system monitoring four key parameters, which is PM2.5, temperature, and also pressure, and also wind speed per minute, which is WSPM. So let me explain to you step by step of the process. So the first is we begin by importing our essential libraries. So as you can see here, we use pandas for handling and analyzing our data set, and then the request library is to I'm sorry, to set because our library is to send data to ThinkSpot, and the GDown is to download the dataset directly from our Google Drive. And also additionally, we use JSON to format the data for ThinkSpot, and time library to introduce the delays between each transmission. So after that, we actually do the things, we set up our ThinkSpot credentials, which is include the access token, which is actually uniquely identifies our device in ThinkSpot and the API endpoint. So which allow the script to send data to the ThinkSpot platform. After that, we proceed to download the dataset from the Google Drive by using the file ID. We construct a download link, as you can see here, and we use the GDown library to fetch the file. And then the dataset is saved locally as a CSV file. And then once the dataset is downloaded, we load the dataset into a pandas data frame for easy processing. So this step actually helps us to structure the data into rows and columns for analysis. So if there are any issues with loading the dataset, the script will actually logs the error and stops, ensuring that the problems are caught early. So now come for the main part. which is the streaming streaming the data to the ThinkSpot. So the script iterates. Here the script iterates um through each row in the data set. So for each row, it extracts the value for each of our variables, which is PM2.5, temperature, pressure, and WSPM. And then the values are stored in a Python dictionary. So this dictionary is then converted into JSON format and sent to ThinkSpot using an HTTP post request. So this allows the data to be displayed on ThinkSpot dashboard in real time. So to stimulate the telemetry, we actually introduce a delay of 0.8 seconds between each sending row of the data. So this ensures that our system doesn't overload the server and actually mimics real life data streaming. So throughout the process, if an error occurs while processing the data, it can actually be covered throughout the process. It can actually be covered. So the script logs the issues and moves all the and moves on to the next row, ensuring that the process is actually smooth and resilient. So now, as you can see, the code is actually running here. So now we can move to the ThinkSpot. So this is our dashboard. So we put a gauge widget and line graph and also alarm system. So the gauge widget here is to providing at a glance view. So overview. And then so here I set up for PM 2.5, temperature, wind speed, and pressure. And this is also the four of our variables also. As you can see, it's still moving. Through with our data set. This is our line chart, which is actually plot historical trends and help us to track any changes. So here, as you can see, for all of our four variables, and then this is for our alarm widget, which is, as you can see here, for us to track the critical and warning alarm. So here, as you can see, for the PM 2.5, we actually set it for between 100 and 150 microgram per meter cubic. So this, because the PM 2.5 is an indicator of the pollution caused by vehicles, industry, and also construction. So this actually here is two different one, because this one is for 100 and this one, the critical one, the warning one is for 150. Next is for temperature. We set it below 5 degrees. So this, because this temperature caused by temperature inversion can actually trap the pollution, pollutants close to the ground. So the pressure part here is above, we set it above 1020 hectopascal, because high atmospheric pressure creates condition that worsen the air quality. Next is the WSPM, which we set below 2 meter per second, because low wind speed can prevent the dispersion of pollutants, leaving them concentrated in the city. So in conclusion, all of this of real-time data streaming, visualization, and alarm notification ensure that our system is actually effective, monitors air quality, and help to mitigate the risks. So that's all from me. I will pass this to Aliya to go on with the conclusion part.
So in conclusion, the system monitor key parameters like PM 2.5, temperature, pressure, and wind speed, and that provide real-time data to ThinkSpot dashboard. This dashboard allow user to track live values and analyze trend and receive critical alert when pollution level exceeds safe threshold, and enabling quick response to protect public health. This aligns with Sustainable Development Goal, which is SDG 3, that's good health and well-being, and SDG 11, which is Sustainable City and Communities. The system reduces health risk by ensuring timely alert and support data-driven urban planning. It helps optimize green space, control traffic emission, and improve city layout, contributing to long-term sustainability. In conclusion, this system integrates real-time monitoring, visualization, and provide alarm to create healthier and more resilient urban communities. So that's all from us. Thank you and bye.